from the previous chapter. The first law tells us that in an initial frame, if there is no force on an object, the acceleration is 0. Okay, so it means that if you are on an inertial frame, okay, you are on an inertial frame, and you look at an object, and if you know that there is no force, F equal to 0, so you know that there is no acceleration, so it means that A is equal to 0 too. This due to the first law. And if A is 0, so it means that the velocity of the object is 0. Oh, sorry, the velocity of the object is a constant. Okay, it may be remain at rest. It is the velocity is 0, or it moves with a constant velocity. We will call the observer on this inertial frame as A. Okay, and we will call this object as P. Now, if you have another observer on another frame of reference, okay, and we call this observer as B. And if B moves with an acceleration relative to A, we know that B, the reference frame of B is not an inertial frame. This is because you can see that from the Galilean transformation, B will see that P, when B looking at P, he or she will see that P move with an acceleration. Okay, P will move with an acceleration. For example, imagine that if P is at rest relative to A, but B move with an acceleration, so B will see that P move away in this situation. P move away from B with an acceleration minus of A, B, A. But both A and B know that there is no force on the object. There is no force on the object. So B is non-inertial frame. That is, B observes the acceleration on P, even though there is no force on P. We can see that the observation of B on the motion of P is against the Newton's law of motion. We have that relative to B. First, there is no force, but B observed and acceleration on P. This against the first law because we know that there is no force, but you observe the acceleration. The second is that because you see that P move with an acceleration, so you have that F is not equal to ma, right? Because in this case we know that F equal to 0. There is no force on P, but ma is not equal to 0. So this against the second law. You have the term ma, but it's not equal to F. However, this term ma has real effect on B, or on the observer on B, the observer B. And the observer B may feel something like force because he or she can feel the acceleration on the object or even on his or herself. But this is not the real force, and we call this ma term as the fictitious force. Fictitious here mean it is not real, because we know that there is no force, but the acceleration comes from the effect that the frame of reference is not the inertial frame. And the third is that there is no reaction pair for ma. There is no reaction pair for ma because ma is not a force. ma is not a force. It's not come from the interaction between two objects or more. It means that there is no interaction. ma comes from the effect of the non-inertial frame of reference. So you cannot have the reaction pair because there is no interaction. So this is against the third law. A most familiar effect on the non-inertial frame may be when you are in a car that is turning, as in this figure. In this figure, the car turns left, right? If we assume that the Earth is an inertial frame, we assume that the Earth is an inertial frame. So when the car turns left like this, you can see that the car moves with an acceleration. If we assume that the path of the car is a circle, so it's subject to the centripetal force and centripetal acceleration. So it means that the car is the non-inertial frame. And when you are in the car, you may use the car as your frame of reference. So you are in the non-inertial frame, and you will experience some fictitious force. For example, if you are in the car and you sit in the right seat, and when the car turns left, you may feel that you are pushed. You are pushed to the right. This is a very common experience. The question is that who pushed you? No one pushed you, but that is the feeling because you are in the non-inertial frame, and you feel that you are pushed to the right relative to the car, right? And now the car is the non-inertial frame, so you feel this force that pushed you is not real, but it is a fictitious force. Okay. However, if you move with the car, it means that you are now moved in a circular path. So you need the centripetal force that will make you move in a circle with this car. The real force is the friction. Okay, the real force is the friction at your seat. It is a static friction at your seat, and you can see that this friction will point to the left. Okay, the friction will point to the left, and this makes you move in a circular path. So this is the real force. This force is fictitious. It's not real. So this is an example of the effect of the non-inertial frame and the effect of the fictitious force.